おはようございます。今日の朝のフーディニ作業配信を始めていきたいと思います。今日はシミュレーションだとよくある、こうシミュレーションされる領域が徐々に広がっていく、感染していくような演出があると思うんですけど、あれで、ちょっと長いんですけど、ちょうど良さそうな動画があったので、それをやっていきたいなと思ってます。事前に、見てるんですが、パイロソーススプレッドかなを使った割と取り入れやすい感じのセットアップなので、結構使いやすいんじゃないかなと思います。はい。では、動画を流します。
I'm gonna use a geometry here for our tutorial, and you can actually go to 3dscans.com. These are all free objects. In fact, if you remember from one of our previous videos, we used this one. For this video, I'm gonna be using this, I don't know what it is, this Jaguar, or I don't know. We're gonna use this one, whatever it is. Let me scene as well, because I want to see what I'm doing. There we go. Let's place down a G.
待って待って待って。OK かな。
Geometry node. Let's place down a file.
じゃあ、フーディニに切り替えていきます。今回は、バージョン19でやっていきます。
Here we go. Let's place down a G.
ファイル。なんかおかしい。ちょっと待って。そういうことか。 事前に OBJ ファイルを落としておきました。さっきの 3dscans.com という、なんか石膏のフリーモデルが落とせるサイトがあるんですが、結構他のチュートリアルとかでもよく使われる、天使っぽいやつだったり、カニだったりとか、ドラゴンだったりとか。なんで、お気に入りにしておくと良いサイトだと思います。
Geometry node, let's place down a file, and I'm just gonna load it. Now, most of the time when you load objects from 3D scans, or in fact anywhere else, they're gonna be kind of weird, distorted. Maybe the orientation is not correct. This is usually because of the method that they use for the 3D scan. So what I'm gonna do here is I'm gonna put down two nodes, match axis and match size. Now these two are actually very helpful. I'm gonna go to the match axis and I'm gonna say, let me actually save this one real quick. Tutorials. Didn't I already save this one? I guess not. No worries. Selected system, and I'm gonna call it selected tutorial. So, match axis. We have from vector 0, 1, 0, and we're gonna say -1. So immediately we see the orientation is correct. Now let's go to the match size. We're gonna say justify y, the minimum. So it's gonna sit on the ground. In fact, you can also offset it if you want. Go up and down. But the scale is too big right now. And the thing is, you can scale it to whatever value you like. In fact, there's like a target size in here. You can say
めちゃくちゃでかかった。45、めっちゃでけえな。
scale to fit. It's gonna go be very small. In fact, it will be the biggest. Essentially, the biggest axis is gonna be 1. The way it's set up here, you can actually set it to be like you want your x direction to be 1, which is what's you can see right now. You can go with y. You can go with z direction. I'm just gonna leave it as best fit. But I'm not gonna use 1, 1, 1. I'm gonna use 3.5, I think. Yeah, in my experiments, bigger values with the way this setup works are kind of better. You're free to just experiment with whatever number you like. Now, we have a lot of details in here. And we're going to use this geometry for the render, but I just prefer using a little bit of a less denser geometry for our simulation. So, VDB from Polygon, trusty old friend, and I'm going to set it to 0.008. These values, I just experimented with them, so I know they work, but you're free to go with higher resolution if, in fact, lower resolution. If it's slow, you can go to like 0.1, 0.15. I mean, I guess this is too small, but 0.05 might work. 0.01 might also be fine. But I'm gonna go with 0.008. And I'm gonna convert 3dB. Set it to be polygons. And we have our geometry, but it's still pretty dense. So 500,000. This was about 1 million. So I'm gonna also put down a remesh node. Now, the remesh sub is pretty slow. I'm not the biggest fan of it, but we're gonna use it right now. I'm gonna also show you an alternative. So let's use adaptive. And I'm gonna set these two values. Just waiting for this thing to load. Okay, so for the
遅いんだよな。
relative density, I'm gonna put down, let me also manual because it's gonna be super slow. I'm gonna put down one in here and also one in the second one. So now let's set it to on mouse up. It's a better method, I think, because then when you're changing something, it won't constantly load it. As you can see, this is actually much better now. We won't use this one for our render, because if you look here, there's just so much more resolution, and it's just better. But for our purposes, and in fact for the simulation, I think this is pretty good. All right. Now, as an alternative, there's a node called Fast Remesh, and it's not available by default, but it was available in side effects competition they did a while ago. I'm not sure where it was. I think it was called Tech Art, if I'm not mistaken. Art, was it? Let's just see. Heck. Should be able to find it. Art challenge, yes. So, if you want to download these, you can go to the forum. I think it's in one of these categories, but let's just go to the forum itself and best utility in trees. And if you scroll down here, pretty much near the end, I think this one, the Fast Remesh. It's an amazing node. I'm hoping the Labs tools will actually load this one because it's just amazing. Now, when you go to it, you just bring this one up. As you can see, it's pretty fast. You set the target length, and just it's great. And there are sims, and if you don't like it, you can just check this one, and it remeshes everything. And as you can see, it's a great way of remeshing stuff. I'm not gonna include this one in the scene file because I'm not sure if I can share it, but you can just go there and download it. We're gonna go with our
なんかさっき見てもらった動画の中で、ユーティリティとしてダウンロードできて、自分のプロジェクトに入れることができるようなので、興味のある人は入れてみたら良いかと思います。自分もダウンロードして、ちょっとめんどくさくなってまだ入れてるところまでやってないので、ただ、リメッシュやっぱ遅いので、めちゃめちゃ早くて、早すぎてビビります。
normal read. All right, so we're gonna use some Pyrotechnics. Actually, we've used similar techniques before in the Willemite crystal tutorial, but I'm just gonna walk you through it again. So, first things first, we are gonna create a pyro source. Let's place it right here. We're not gonna keep the input. Let's go with surface scatter. It's more uniform because if you look at it, for example, you can see there are some points that are closer to each other. You can go ahead with this one as well. It's just I prefer surface. You can also go with volume scatter for normal stuff, but let's just go with surface. And for our separation, I'm gonna put down 0.025. I think it's a good value. I'm gonna create the hit this plus button, create the temperature. I'm gonna set the value to be 0. Now, we're gonna work with temperature.
Okay. これで選べたっけ？これ、お前手打ちでやってたような気がするけど、選べるようになったのか。
Let's scatter some points. Now, essentially the way it works is I'm creating these particles in here. I'm setting the temperature attribute, but it's gonna be equal to 0. Now, usually when we work like this, we're gonna put down a pyro spread. And the pyro spread is a simulation. If you have a temperature value, it's gonna use that and do something with it. For example, burn your scene. Well, we don't have any values in here. In fact, let me just put the scale to 0 as well. There we go. Now, here, in fact, let me just, for example, burn your scene. Well, we don't have any values in here. In fact, let me just put the scale to 0 as well. There we go. Now, if you have a temperature attribute, it's going to be red in here. In fact, if I bring it up, should be, I think since it's just one value, it's not showing it. Let me check real quick. There we go. So this is like the temperature. But we don't want to work like this. What we want to do is we want to pick some of these and give them the temperature so they spread. We don't want it to be on the whole geometry. So the way I'm going to do that, I have my points in here. I'm going to bring it down. I'm going to disconnect this for the time being. I'm going to scatter a bunch of points. I have my points in here. I'm going to bring it down. I'm going to disconnect this for the time being. I'm going to scatter a bunch of points. Now, you can very exact place them by hand. I'm just going to do something random. Let's see. I'm going to place 9 points, maybe. Yeah, that's fine. So what I'm gonna do next, I'm gonna put down a sphere, and I'm gonna copy this sphere to these points. So CTP, copy to points. They're gonna put down a sphere, and I'm gonna copy this.
いきなり作ってなんでポリゴンができるんだ。セットアップ変えれんのかなこれもしかして。
Sphere to these points. So CTP, copy to points. They're pretty huge. We're gonna make them smaller. Now I'm gonna put down an attribute randomize. I'll randomize the p-scale attribute. Bring it down and fit it between 0.05 and 0.1. Now, alternatively, you can also use adjust float, which is probably better because it has a lot of options, including the random. And by default, it puts p-scale. So, in fact, let's just use this one. The random. And a lot.
Just float. 新しく出たやつか。最初から P スケールになってるんだ。
A lot of options, including the random. And by default, it puts p-scale. So, in fact, let's just use this one. So, 0.05 and 0.1. There we go. What I'm going to do next, I'm going to put down a sphere. This one. So 0.05 and 0.1. There we go. Now, next up, we're going to create a group. I'm going to say group. I'm going to change it to be points. I'm going to call it, I don't know, I guess B-box. Since we're going to use bounding regions, and we're going to switch it to bounding object, and we're going to connect this one. So now we're selecting these points. I'm going to put down angle. You can also put down an attribute create, it doesn't matter. I'm gonna select this group. I'm gonna say assign temperature is equal to 1.
綴り間違えそうだ。テンペラチャー。
So now when I visualize this temperature, you can actually see some of them have this value.
なんで全く同じ値入れてんのに微妙に動画と場所が違うんだろう。
Value of 1. So let's connect it to the Pyro spread now. Let's visualize the burn. You can just go through these and visualize the one attribute that you want. When we play, we start to see something, but then it dies out pretty quickly. So let's dial in some settings. Now, first things first, I'm gonna play with this cooling rate.
遅いな。
So let's say 0.3. When I play it now, you can see we're actually seeing something, but it's not enough. It's kind of boring. You can also visualize temperature if it helps better. Yeah, maybe this one's better. Okay. So let's go to diffusion. Now the diffusion is sort of like how it's gonna burn. So diffusion rate, we're gonna switch this one. I like alligator noise. There we go, it's pretty cool. I'm gonna bring this one a little bit forward, as you can see. And by the way, you can actually see the effect of this on mouse up. Here, so if I put it to auto update, you can see whenever I move it, can see what's happening, but if you put it to on mouse up, when you stop it, you get to see it. Now, it might not be so useful right now, but if you're doing something very heavy, it becomes very helpful because you might want to go between values and you actually have something specific in mind. So I'm going to leave it somewhere here, and I'm going to bring this one, well, maybe here. Yeah, that looks good. Element size 0.5, and for element scale, so I'm going to bring it to 0.5, so small. And I think that's pretty good. Let's look at the temperature now. Very, very interesting. Okay. But it's still a little bit fast for me. So what I like to do, it's a kind of a trick, but I put down an attribute warp, I jump inside. Now here's the thing, we have this burn attribute. This node by default puts out a bunch of attributes. In fact, these are the stuff that we are visualizing in here. We're going to work with the burn attribute. It's here. And it's going to show how much of this thing is actually burned or infected. So I'm gonna bind my burn attribute. What I'm gonna do, I'm gonna actually multiply it. So let's put down a multiply. I'm gonna put a noise on it. So my position, I'm gonna put a noise and connect it here. And connect it, not to P actually, bind export and connect it back to burn. So sucks now because it's just too small. You gotta dial it up. So I dialed it up to these values. So for amplitude, I used 17.8. I brought down this roughness to 0.082, and I also changed the frequency to 5.9. These are just values I experimented with. And when we play it now, you can see it's actually really interesting. But here's the thing. We're multiplying this by a huge number now. And when we go to our geometry spreadsheet, a burn, it's actually pretty big. Like, we don't want that. We want 0 and 1. So let's just clamp it. But it's going to be between 0 and 1. So still has the same effect. It's just between 0 and 1 now. Great.
変わってる。違いがないんだか。ぐらいして、書き合わせてクランプして戻すって。なんででしょう。
5.9. These are just values I experimented. And when we play it now, you can see it's actually really interesting. But here's the thing. We're multiplying
変わってんだよ。ちゃんとクランプされてんだけど。もう一回シミュレーションした方がいいのか。もしかして。いや、でもシミュレーション後の値の格好だからシミュレーション関係ないじゃん。やってるかわかんねえ。いつかけんのやめるか。水かけてると微妙な値が入ってんだ。やっぱ01しか入んない値にノイズを入れてるとしか思えないんだか。やっぱそうだよね。01しか入ってない値に だいぶ上がった。テンパチャーで見てるとわかんねえんだ。バーンで見ると、ちゃんと01じゃないようになってるのか。仮にく。
This by a huge number now. And when we go to our geometry spreadsheet, a burn, it's actually pretty big. Like, we don't want that. We want 0 and 1. So let's just clamp it. This way it's going to be between 0 and 1. So still has the same effect. It's just between 0 and 1. Great. So let's put down a loop expression. And in here, we're gonna select these. So let's say, you can put whatever name you want. I'm gonna say infected. I'm gonna say sign burn is equal to 1. Let's select it. So these are our points, and we're gonna just blast them out. Blast the infected and delete non-select. So these are our starting points. Now, I'm gonna clean our setup now. Make sure uncheck this. I'm gonna clean our setup. Now, make sure uncheck this unused points, because, and also this one, the remove degenerate primitives, because we want to keep our points, and just check these two. So now we don't have any attributes. Clean. Let's put down a popnet. Now we need to actually come back here and change something, but let's just keep it like this. Also, we had a p-scale attribute. Since we're cleaning our setup, now we don't have the p-scale attribute. I'm actually gonna put this caret symbol and say p-scale, because I want to preserve the p-scale in case we need it, because right now it would be equal to 0 if I don't. But overall, we usually actually don't include this one. Let's just keep it for now. We're gonna see some problems. We're gonna come back. The only reason I'm keeping it is because you might forget this clean. So let's just go without the clean, and then we're gonna come back to it. Yeah, that's better. Don't include this one. Let's just keep it for now. We're gonna see some problems. We're gonna come back. The only reason I'm keeping it is because you might forget this clean. So let's just go without the clean, and then we're gonna come back to it. Yeah. That's better. So let's create our stuff. This one. Okay. So let's just start from the top. I have a bunch of points. What I'm gonna do is I actually learned this trick from Doxio Studio, and if you wanna check his tutorials, it's great. You definitely should. In fact, he actually takes a similar approach. It just I think he uses PC Find, but it's pretty much same. I think his method is harder, so this is a pretty easy version of kind of similar stuff. So let's put down pop grain, and we are gonna change some stuff in here. First of all, assume uniform radius. We don't need that. Clumping, we need. Uniform radius, we don't need that. Clumping, we need that. And that's it. I don't think we need anything else. So let's just play it right now. We're creating points on top of each other. And also I'm gonna set this one to all points. Here. There we go. Now, they are clumping, but it's terrible. So, how do we fix that? One thing that we need to do right here is setting the velocity to 0 on each frame. So, v at v, you don't actually need to say it's a vector, just you can say sign v equal to 0. Let's play it. We're getting something. But it's uniform. It's because we have this p-scale attribute up there. Now, if I set the p-scale to 0, assign p-scale equals to 0, this will be resolved, but then we won't see. Anything. But if you, this problem will be resolved, but then we won't see anything. But if you turn on this number in here and see that we are actually placing points on top of each other. So p-scale is equal to 0, but we're putting them on top. So that's why I put down the clean equal to 0, but we're putting placing points on top of each other. So p-scale is equal to 0, but we're putting them on top. So that's why I put down the clean. You don't need to say p-scale equals to 0, and we don't need to actually exclude it either. You can connect it directly, and it will still give you the same results. The only thing is it's equal to 0, so essentially the same thing. Let me just a bit nicer. Yep. So what I'm gonna do now is I'm gonna add something to the p-scale. I'm gonna do it before the sign. P-scale, I'm going to say p-scale plus equals and a value like 0.00. Let's check it out.
近すぎてもか。
Working now. Great. But then it's growing to infinity. So we need to clamp it. So line p-scale equals to clamp sine p-scale, and we need two values. So I went with 0 and 0.01. So essentially it starts from 0. We add 0.001 each frame, and when we get to 0.01 we're gonna stop. Now when we play it, it's gonna grow up, but then they're gonna pretty much stay in the same spot. Great. Now we're pretty much done in here. The only thing is, if I actually come out here and let's see, let's add a null down here from our for our object. Now let's just merge these two together. Now if you go inside, there's no collision. Let's make it collide with our statue. Put down a merge in here. And I'm also gonna line. I'll put down another merge because I also want to include a ground. So let's put a static object. Also, let's put down ground object, ground plane. Let's merge them together. And make sure you're not connecting them like this. It will kind of fail. It's not how Houdini likes it. Let's merge them together.
ああ、そういうことか。シミュレーション戻さないと出てこねえのか。
Down, ground object, ground plane. Let's merge them together. There we go. And make sure you're not connecting them like this. It will kind of fail. It's That's not how Houdini likes it. The order operations matter. You should either put it like this or come here and say mutual relationship should be mutual. So both work fine. So if it's like this and it's set to mutual, it's fine. But I kind of prefer doing it like this.
Relationship. 見れた気がする。これか、アフェクターマトリックス。
We have ground, and then we want to add our collision. So for ground, 0.15 I think worked. Let's just check it out with our object as well, but let's also bring our object. So worked. Let's just check it out with our object as well, but let's also bring our object. So we need to put down some nulls. Now, I'm going to use this remesh for our slider. So out, call it call. Let's copy this, dive inside, and paste it in the subpath. There we go. And when we play it, we start to see something. If you go inside, it's still, as you can see, they're going inside. And one way that you can actually visualize this is go to collisions, uncheck display geometry, and check the collision guide. And as you can see, this is the act.
これじゃおかしいぞ、これ。なんでこんなコリジョンになってんだろう。ちゃんと入ってきてないな。 ッシュだよ。コリジョンがなんで聞いてねえんだ。
Actual collider that we have in here, which is terrible. Now, one thing that you can do is you can just bring this up, go to the first frame, and you start to see something.
なんかおかしいな。なんだこれ。なんでこんなコリジョンが効かねえんだ。これはわからんぞ。
But it's still not really good. So what's the best way to do this is actually using a volume. Now we already have this VDB up here, so I'm just gonna bring another null. You don't have to bring nulls, but I mean you should, because you need to stay organized. So I'm gonna call this one out. All vol. So copy this one, go inside. Now if you scroll down here, you see a proxy volume. Call vol. So copy this one, go inside. Now if you scroll down here, you see
マジでコリジョンが来ない。なんでだ。
a proxy volume. I'm gonna paste this one, but nothing really happens. You need to come up here and say volume sample. Now we actually see our object. It's so much better.
なんだこれ。メッシュ作るときになんかミスったかな。
Okay, now you shouldn't keep this one on because it will slow this down quite a lot. As you can see, I'm actually playing it right now, but it's super slow. You can uncheck this. You can visualize your geometry, and when you play it, it's actually pretty fast. Great, it looks really cool. And also, it's not really going here, but when we play it, start to see some weird stuff happening. In fact, maybe will be visible on the inside. Probably if you look around, you're gonna see some problems. Even though we have this collider, and let me actually uncheck the guides here. There we go. So yeah, there are some stuff down there. In fact, you can also uncheck this. And it right here. It's not perfect. So how can we fix that? My solution is to actually come up here. My solution is to actually come up here when we're scattering the points. Now I'm just gonna clip my geometry. It's pretty easy, but it's actually pretty helpful. Now I placed my
なるほど。下切っちゃうのか。
ground on 0.15, so I'm just gonna use the same value. In fact, I'm gonna copy this parameter. Dive inside my popnet and place it in here as well. So they're gonna be related to each other. Now, another thing that I'm gonna do is I'm also gonna
これを渡さなきゃダメじゃん。
I'm gonna connect my pyro source to my clip. So this way, my object object is actually clipped. It's not the full geometry. So now I don't have to worry about my points going under this particular surface that I put there, and there are like some seeds that would have gone down there. Because right now it looks pretty good, but playing with our global seed, you might come across something that you don't like. This way, you're just cutting anything beneath it. Let's go back to our PubNet. Now we're gonna play it, and it's gonna be much better. In fact, we're not seeing anything. Anything down here. Here. Now we're just gonna go around. Yep, nothing. Great. Let's just let it play, and I'm gonna take a sip of water. There we go. So I think around here is just fine.
頭痛がひどいな。
Let it do more frames. Okay. And also you can just increase these values. You can increase your cache size. Probably this would be better. So let's just simulate it. I'm gonna stop around 72, which I think is pretty much like this best frame for us. Now, also I forgot to name this one, so I'm gonna call it out. Statue, because this was coming from our actual geometry. It's gonna be the render geometry for our statue. So one problem, we're actually seeing this static object here, so I'm just gonna come here and say pop and this asterisk sign, so see that. That anymore. If you want to see that, you can just merge these two together. Now, next thing that I'm gonna do, in fact, let's just merge it. Well, for rendering stuff, we need to actually disconnect it, especially with Redshift, since we're gonna render points. But if you want to see geometry right now, you can actually put down a sphere. I would recommend using a primitive because it gets heavy fast, and use a copy to points, and there you go. Now you have geometry. Oh, we're not going to render it like this. So let's do something cool. Let's add some color. I'm gonna put down attribute, adjust color. I think it's a new node. I think they introduced this one in 19, or maybe it was one of the last builds of 18.5. Let's actually check that real quick. It help tool, and it was introduced in 19. Yep. So we're gonna come here. We're gonna say let's remap an attribute. Now, I'm gonna use the age attribute, which we're getting from our topnet, but I'm not gonna use this range. I'm gonna use 0 to 4 because it's just interesting. Or you can actually use 0 to 5. It would be pretty much like in the middle. I think 0 to 4 is better, but let's use one of these presets. Let's use Twilight. That's pretty cool. And I would recommend not using the geometry, as I mentioned, make it slow. Let's just use points direct. we're gonna keep this one as a visualizing help tool, but let's wait for this thing to go forward a little bit. Perhaps frame 120. There we go. That's cool. Okay, we're pretty much done in here. Let me just stop the simulation. And I guess we can wait for 170 frames just to see how it would. There we go. It's too bright, but I think it works. And we're probably just gonna end it somewhere anyway. So we're gonna remove this merge. We're gonna add a null. Call it out brains. Maybe copy this, go out here, another geo, jump inside, go out here, brains, maybe copy this, go out here, another geo, jump inside, object merge, paste it. Now I made the mistake of not naming these, so let's also name them. But the thing is, this one is gonna get destroyed. Our cache will be gone as we're changing the name, and I'm gonna call this one statue. You can also call it setup if it's easier for you to follow this way, because all our setup is inside here. This is just for rendering. I wait for this remesh as well. Okay, so pretty much have everything. One that can do is also include a grid. Merge these two together and put down a null, say out render. Yep. You can also put down output node in here, so that even if you're like where else, when you jump out here, it would automatically where else output. mode here so that even if you're like or else, when you jump out here, it would automatically load the out. This is in fact what happens inside a PopNet or any other simulation. We have this. Oh, it doesn't really matter.
Okay, すんかい。ダメだ。頭痛くて頭が回らなくなってきた。
So let's just simulate one more time and see what happens. Okay, somewhere around here is fine. Let's set this to show all objects and go to render.
ダメだ。ちょっと。今日はちょっと頭痛がひどいので、あとはここで一旦終わりとして、ちょっとレンダリングは後でやっておきます。はい、すいません。じゃあご視聴ありがとうございました。